may plan we may plan to take screenshots for social media. If you're comfortable, turn the video on. If you want to be anonymous, turn the video off. We will make some time for Q&A at the end of presentation. Feel free to take notes. Online even best practices. Don't multitask. Distractions reduce your ability to remember concepts. Mute yourself when you are not talking. We want the session to be interactive. Use the raise hand feature to ask questions. By attending our events, you agree to comply with our code of conduct. I'll just give a brief introduction. Welcome to Women Who Code. Our mission is empower diverse women to excel in technology careers. Our vision is the tech industry where diverse women and historically excluded people thrive at any level. Today's session is for the backend study group where we learn this and discuss backend topics. I am the host for today's session, and I'll give it over to Prachi.
Thanks, Anjali. So hey everyone, welcome to part 3 of the series of system design sessions. And I'm Prachi. I'm a senior software engineer at Unity Technologies in San Francisco, and I'm a director at Women Who Code. Today's topic is about basically how can we interview for system design rounds, and we will just solve one system design interview question, a very commonly asked question. And then Q&A would be at the end. You can also add your questions in the chat and we can go through them. So just quickly, what is backend engineering? In backend engineering, we design, build, and maintain server-side web applications. So it's basically everything that the user or a client wouldn't see. This can include business logic, this can include database, data manipulation, and domain knowledge, and basically core infrastructure, all of it. Some of the concepts that you need to keep in mind or know when you're doing backend engineering is client-server architecture, networking, APIs, web fundamentals, what are microservices, databases, security, operating systems, and a lot of infrastructure side of things. Some of the tech stack, which would be considered backend, would be Java, PHP, C#, AWS, Node, SQL, etc. The system design. So what is system design, right? Why do we do system design? Usually we are doing system design is when we want to architect a system, and that system, we are architecting it either to solve a problem that exists, or we are trying to build a new product or a new service. And that is why we need to design a system, right? Some of the things we do when we're doing design is defining an architecture, defining what the modules would be, the interfaces or communication, and the flow of data between all the different modules that we are designing. Architecture means what is the behavior of the system, the high level view of the system, right? Like what does the system entail, and what is its behavior or its features or expectations? That is what we'll consider architecture. Modules would be a little bit specific, where you do a little bit detailed design, where you're thinking about each module or each service in your design and how these things are interacting with each other. So you want to have specific modules doing specific tasks and specific expectations from each module. Interfaces is basically the communication. You have all these modules. How are they going to communicate? What is the technology, right? Is it APIs? Is it something else? How would the communication within your entire system happen? But also how your system interacts with an external system that you may need to communicate with. So you need to think about that as well. And data flow would be basically pretty much every system collects some kind of data. So what does that data flow look like, right? Within different modules, within your entire system, from front end to back end to data store, everything. So basically, when you think about system design, you're thinking about defining the input to your system, you're defining the output, right? The nature of data, what the input output looks like, what the features are, what the business rules are, if it's very domain heavy, your system, and what the data schema is, right? You can deal with all kinds of data, and you need to define what the data structure or data schema looks like, right? whatever your data schema for front end is, it might be very different from how you actually storing data in your database, right? Downstream. So stuff like that is what you think about. 1 second. Yeah. So interview, when it comes to system design interviews, a lot of companies, they won't call it like a system design interview. They would call it like a backend interview or application design interview or software engineering interview. The name can change from company to company, team to team, but usually they are trying to understand your design skills, your knowledge of architecture, your knowledge of tech stack, etc. So that is what they're trying to basically understand, right? So during the interview, this is a very open-ended interview. They can ask whatever they want. They can talk to you about an hour. They can talk to you about like a particular tech stack for an hour. They can talk to you about like domain knowledge and business knowledge for an hour. They can also talk about product design. So it varies, but usually when you're giving these kind of interviews, you want to talk a little bit about the product and the design. You talk about different components. You want to understand what the data and the flow is, and any kind of integrations, internal or external integrations that you had. So whenever you are working at any job or anything, like try to understand how your systems and infrastructure is designed. If you're at a company working on a product, you can be a front-end engineer, back-end engineer, whatever you're doing, full stack, whatever, right? Even DevOps. They try to understand like what your product is, what are different components, what does the data flow look like, what are the integrations, what are the tools you're using. I think it's very valuable when you change your job and you're doing system design interviews. These are some of the things you're going to be asked and you can talk about, and you can like really do well in these kind of interviews. So knowledge is very important of the infrastructure and the system. Some of the examples, right? Like, so some of the things they can ask you is they can talk to you for like about the front end. Hey, this is your system, right? What does your front end look like? Can you like walk me through it? You have a mobile client, you have a web client. Like, what does that look like, right? They can talk to you about that. They can ask you core backend system, right? Like, hey, what are some of the APIs your service had? You know, was it a monolith or a microservice? Why did you do that? Right? Stuff like that. They can ask you about different models, right? You know, how did you design your data schema? How did you design your models, right? And your entities? What are some of the constraints, right? What are some of the ways you do data analysis? So give me examples in the name of like SQL queries. Was it relational data, non-relational data? Why did you do that? So stuff like that, they can ask you. Database, again, that would be like the tech stack. And then they can ask you about like, did you have an API gateway? Did you load balance it? What kind of servers did you have, right? Stuff like that. Was your system on-prem? Was it in the cloud? All of these questions are very common questions. So knowing how your systems are working and how you can understanding like the high level design, your right or architecture of your infrastructure, but also like detailed becomes an important skill. There is some framework to like addressing such kind of interviews, right? So bear in mind, this can be open-ended questions. It can be something like, hey, can you design YouTube for me? That's it, one line. Like, now how would you do that, right? So now you have to manage the interview, and you know, you have to be like, can I design YouTube for 10 people? Let's do that first. Then we will design for like 50 million people. How about that? If time permits, great. You can do that. Or you can be like, let's just design YouTube the way it is today. And these are the 10 things I would do when I'm designing YouTube, right? It can be as simple as that. You can say something like, can I design YouTube just for like mobile apps and not the web? Fine. Okay, if your interviewer is fine with it, cool. Just spend an hour in the interview just talking about that and nothing else. So it can be very open-ended or very generic question like that. Or they can be like, hey, you know, you worked at Amazon, right? You worked at Amazon.com shopping cart service or Amazon online shopping, right? Can you design that product for me, the product that you worked on in your previous job or in your current job, right? Can you design that for me? And you might be working a very small team at Amazon, but they might ask you to design the whole thing. So something very generic or something based on what you were actually working on. And they might design AWS. That's a good one. So yeah, stuff like that, right? They can ask you to design a core. If you're at a startup, let's say Calendly, for example, and you know, they can ask you, hey, you're working on Calendly, right? Like, can you design that for me? There is no question out there that, except for like maybe Calendly's engineering blog site, there's no article there that talks about design Calendly or design like Figma. How would you do it, right? You're working in that team. So stuff like that. So it can be any kind of question, and the interviewer can go in any direction. They can go like very deep into the tech stack, or just like deep into the data, APIs, the domain, anything. So it's very open-ended. And that's why these kind of interviews are a little scary, because you don't know where the direction of the interview is. At the beginning, you're like, oh, I'm just designing YouTube. In the middle, you're designing like some streaming service and something else. And it's like, okay, that's the interview, fine. That's it is what it is, right? So if you know, if you have all this knowledge, you can do well at whatever the interview throws you, or whatever direction the interviewer asks you to go into. And that's why it's a little bit challenging, and that's why system design interviews, you need to know a lot more. Like I said, understanding of systems, components, interactions becomes crucial, because if your interviewer wants to focus, it's like, it's really possible. Like I have been interviewed by front-end engineers, even though the role was a backend engineering role, and they knew nothing about backend as such, but they were senior to me, and they focused the whole time on front-end stuff and mobile stuff. And I was like, okay, cool, I can talk about it, because I know the front end of the applications and services I have worked on. So be it. If I would have asked them, hey, can you focus on backend, because I don't know much about our front end, then the interview would be very nervous about it, and I wouldn't do well. But because I knew the entire system, I was able to talk about any portion of the system, right? So knowledge is very important here, and understanding these things is very important. Communication and clarity. Some interviewers are very chill. They'll just like give you a vague generic question. Other interviewers want you to be, they are very specific, and they like want you to focus on very specific things. So like understand where they are coming from, confirm, ask questions, and clarify. So like you're not going down like a black hole, like a rabbit hole, right? They asked you something else and you're doing something else. And good interviewers will stop you right there and tell you that, hey, this is what I'm asking, this is not what I'm asking, so don't focus on other things. Bad interviewers, which happens a lot of times, they will not stop you. They will not ask you to like, hey, this is not what I asked. They'll let you continue, and then they'll be in the feedback, they'll be like, this person didn't understand my question, and I asked them XYZ, they talked about ABC, so bad interview, reject. Right? So that also happens. So like, it's very important to communicate, clarify. It's a discussion, right? So like, it's like, think about it as you talking to your future colleague about something, right? And this is discussion, communicate and clarify. Pros and cons and unknowns. All of us don't know everything about everything, right? So like, you can make certain assumptions. You can, about unknowns, you can be very vocal about, hey, I don't know this, but this is what I'll assume. Is that okay? Talk about like systems pros and cons of your design, right? Like these kind of things become important. So if they don't ask, you can say it. If they ask, then you should know the design you're proposing, what are the pros and cons, what are the trade-offs, right? Short-term versus long-term thinking. Like, this is my design for short-term, assuming we only have 100 users that will join our platform this year. But if I have to think about the next 5 years, long-term thinking, and 5 million users joining our product, that's a very different design. It's a very different problem you're solving. It's a completely different problem you're solving. So you need to think about like short-term and long-term, and your design will change. So you can communicate things like these as well. So when you think about system design, system architecture, when it comes to interviews, you need to know these things. But when it comes to like even your real job, right? Like when you're working day to day, when you're designing things, even at your job, like some of these things you should just know within the product you're working on, or even if you're designing something new. Like these are some of the very common system design considerations that everyone should be aware of when you're doing system architecture and design. So scaling, right? So scaling is as your system grows, you get more users, your demands are growing, your application needs are growing, your performance will change. And your system needs to have the same behavior and same performance as your system grows and scales. So like scaling would address the problem of, as the application demands grow or change, your performance expectations need to be consistent. And how do you address that, right? That is what scaling is. How do you make that happen? Availability is your system uptime and downtime, right? Basically, your system needs to be up all the time. If you're a banking institution, your system ideally needs to be up all the time. You cannot afford to have downtime. But if you are some application which is not super crucial, which nobody's using after, let's say, midnight to 8 in the morning, fine, then you can have a downtime at that time, right? Stuff like that. So like you need to define how available your system is, what does uptime mean? And if there's a downtime, how can you schedule it? What does that look like? There are applications which cannot afford to have any downtime. That's a different problem to solve, and you need to address that as well. Reliability would be the system performs the task as expected. Every time I go on Amazon.com and I search for, like, let's say, books, I should be able to see a list of books, right? Like, it should always be the case. The system is very reliable. It performs the task as expected. That is what I expected as a user. The system is delivering it, right? So reliability, always. Robustness is in the scenario where there can be errors or disturbances within the system, or because of something external, your system is resilient enough to deal with that, right? So your system is robust enough to deal with any kind of errors and exceptions or disturbances. Some of them are predictable, so you can plan or design your system around that. Some of them are unpredictable, but you can design your systems around those things as well. So you need to have robust systems. Load balancing, as your users grow, your clients grow, you only have limited resources. If you have limited resources, you need to get better at efficient load balancing. By load here, I mean incoming requests from the clients or the users. So how do you distribute all this incoming flood of requests, and how do you distribute them properly across the resources, the finite resources that you have? So your system is up and running and reliable and available and robust and all of that. So load balancing becomes very important. Your network traffic is distributed across your servers and resources. And there are different algorithms. In the last session, we talked about load balancing in detail, like how do you enable this? We talked about scaling in detail as well. Caching is your data storage layer. If you have very read-heavy applications, if you want your data to be available often, and data needs to be faster, you can introduce a layer of caching, and that can make your system faster and more performant. Data partitioning is, again, distributing your data across systems to improve query performance and also to improve availability. So you would, if you're dealing with big data, lots of data, complicated data, you would want to consider data partitioning to improve your system's efficiency and performance. SQL versus NoSQL, depending on your domain or your application or your features or your product, you might want to either have a SQL, you want your data to be either relational or non-relational. In many big systems, there are both, right? So like you might have like a SQL database, but you might also have a NoSQL store. And now your application needs to be smart enough to deal with these kind of different data sets. Right, and collate them and present a unified view to the user. So like you need to know why you're using relational versus non-relational data, what are the trade-offs, and how are these systems going to scale, and what are the costs that are associated with choosing these technologies. Performance, your system ideally is glitch-free, it's fast, and that is what is called your system being performant. So you can come up with your performance metrics and make sure your system is designed well enough to meet these, is performant and meet these performance expectations. Extensibility, future growth, right? Like, let's say I'm starting a new product and it's something like, I don't know, Figma, right? Like I only designed it for like 10,000 users. Now, suddenly my product is doing well. And now I need to like, it's like growing, my user base is growing. Well, the product I designed is not extensible. Like I cannot extend this product to like design it for more users. My system cannot handle it. That is a very bad design. So you have to keep your system extensible, assuming that there'll be future growth and you might deal with more features and more data. So design patterns help you with this, and there are like very known design patterns. If you go to like our GitHub meetup events page, or even our YouTube Backend Study Group channel, we have done a session about design patterns. So you can definitely refer to that recording, that session. But design patterns help you solve a lot of these problems out of the box. Your system needs to be extensible to quickly add growth, new features, and solve bugs and bunch of different things. Even something like integration with a new technology, you should be able to do that. Error handling and security, right? Some of the error handling can happen on the UX side, user experience side, right? UI side. There are known challenges, validations, error handling around that you can accommodate for. And security, right? If you're dealing with banking data, you need to secure your data. What does that look like? What kind of data are you collecting? How are you persisting this data? If your data is flowing through the system, is it flowing through a secure way? All of these things, and privacy, of course, but all of these things you need to keep in mind when you are doing system design. So these are the very common considerations when you're doing system architecture, system design. All of these things you need to keep in mind. It is possible that your system is very small, you're only dealing with relational data, so you're not even thinking about NoSQL. So you might not even care about like considering SQL versus NoSQL. You might not need to do that. You might not need to think about like extensibility of future growth so much, because you just designed a game. That's it. Like, it's very simple thing. It's not going to have more, like you design chess, it's not going to have more features. There's not much that's going to happen. Fine, just make sure it's scalable, but there is not much that's going to happen, right? Fine, then you don't have to worry about extensibility so much, let's say. So the magnitude of these considerations can be like more or less, it can vary, it's dynamic, but these are all the things you need to, your system needs to be vetted against, your design needs to be vetted against. So system design interviews, right? Like the do's and don'ts. Like I said, right? It's very open-ended questions, or it can be very specific too, depending on the interviewer. You don't know the interviewer's background or expertise, so they might ask you to focus on one thing compared to the other. If they are a bad interviewer, they might not correct you, they might not help you, they'll just let you talk without saying much. If they're a good interviewer, they actually want you to win, they want you to do good, so they will nudge you in the right direction and help you out. So a lot of like the interviewer side is like question mark, wild card. You don't know what's going to happen. You get into the interview, you don't know what's going to happen. So in such a scenario, how can you prepare, right? Like your preparation and your knowledge is the only answer to this, right? That's the only way you can crack a system design interview. It's nothing related to the interviewer that is going to help you necessarily. So you cannot rely on that. So just when you go into such an interview, just go with like open mind, just be flexible. Like, like they can ask you anything, and just given you have the knowledge, and just be confident and try to solve a problem, right? It's like you are going into a brainstorming session and trying to solve a problem. Just have that mindset, and then you'll relax and you'll be able to like address the problem at hand, right? So like that mindset matters. And also like don't assume anything, like like ask the right questions, like try to understand the requirement. If I tell you, let's just design Chipotle, I don't know, or Chipotle drone delivery. This is a question someone asked me years ago. Let's just design Chipotle drone delivery. And that's it. So I was like, okay, cool. Where do we start, right? Like, what features do we want? What is the expectation of the drones? How many drones do we have deployed? In what geographic location, right? San Francisco downtown or Austin? Do you want to only deliver in like San Francisco or the Bay Area, anything, right? So you can ask all these kind of questions to understand, and the interview will tell you, okay, let's just assume we are delivering in San Francisco. Let's not worry about rest of the Bay Area. Let's just restrict it. Great. That is much smaller a problem to solve than delivering Chipotle across Bay Area. It's a very different problem, and it's a scale issue. So like you would completely, like you would address it in a very different way. So stuff like that, right? Like if that's a vague question, ask that, try to like ask questions, understand the requirements. If there's no requirements given to you, come up with some requirements and assumptions in the, and assumptions by, I mean assumptions in like, okay, can I assume that we want to deliver only in San Francisco? Interview would be like, okay, cool. That's a good assumption. That's fair. That kind of assumption, the one that you have clarified, not the one that's in your head, right? So come up with requirements. Is there any need for domain knowledge? Like, for example, if the interview asks you, let's just design like a hedge fund. Well, do I need to understand what a hedge fund is? If I don't know, I have to first ask that. So like, what is a hedge fund? Can someone explain me what are the requirements? Who are the people who, right? Like, who are the customers? Is it a bank? Is it a financial institution? What is going on? So if there is some kind of domain knowledge, which you may or may not be aware of, then you will need to understand that too. Like, let's say I'm working on Instagram, but I am applying for a job at Bank of America, and in some very like small team which takes care of people's financial portfolio. And I don't know anything about financial portfolios at Bank of America. Well, I'm going to have a hard time if they ask me to like design something like that. I'll need to understand what a portfolio is, right? What a stock portfolio is, what are we doing here? So that's domain knowledge. If you're coming from a different industry or company, you might want to, and that's the kind of question they are asking, which is very common. People in these interviews ask questions related to the products they are solving or the problem they are solving. So domain knowledge might be important. So you want to ask these kind of questions as well, and really understand and scope it out. Note all the topics you want to discuss, right? Like, do you want to talk about APIs? And do you want to talk about data schema? Do you want to talk about infrastructure? Is that just it? Or do you want to talk about like scaling? Do you want to talk about like what kind of front end we'll have? Do you want to talk about like all the different data storage we'll have? Do you want to talk about like monitoring and security? What do we want to talk about? The interview will tell you if you ask this question. Let's just focus on like APIs and data schema. And if time permits, we will focus on like designing the front end, or we'll focus on scaling it, or we'll focus on monitoring and security. They will tell you this. So like, it's really helpful because you're not thinking about like 50 things. You're thinking about 2-3 things which are really important, and you can spend an entire hour on this, and that will show your expertise, that will show your knowledge, and the interview will be much more confident that if this is the person I bring to my team, I can completely talk to them like very nicely about everything, right? So it's like, it makes the interviewer comfortable too, and they can trust you more. So like, ask all the right questions and come up with a list of like 2-3 things and you can literally say, hey, we talked about like 10 things, but I just want to talk about like 3 things, right? Or 5 things. And if time permits, I will talk about the rest 5 things. Is that good? Great. Only focus on 5 topics and don't rush. If the interview is really curious, they'll stop you at any point and be like, hey, we only have 10 minutes. Can we talk quickly about the rest 5 topics? Fine. Then you talk about those things. So focus on what you are trying to do. Visualization helps. If you can draw a diagram, it can be as simple as physical whiteboarding if you're in the office, or online whiteboarding tools. Visualization helps. A lot of people learn through visualization. So if you can draw some diagrams, it can be as simple as something on Google Drive or any one of these like whiteboarding apps. Just do it. Like people will really appreciate it. They may or may not ask you to whiteboard, but just be proactive and just do it. Visualization really helps. Make some assumptions and frame a recommendation. So I mentioned this before, right? Like, now you have asked all the right questions, you're going to talk about just focus on few topics, come with some assumptions, right? Like, I'm going to assume we are building YouTube for like 10 users now, and we will scale up we'll think about scaling and other things later on. And, if you're building YouTube for like 10 people, this is a design I would recommend, right? Or this is how I would solve it. And this is the reasons why this is my design for YouTube, building YouTube for like 10 users, right? So come up with some recommendation, come up with some assumptions, tech assumptions, or even assumptions about the product or domain, because this is all the things you do when you're at your job designing. So it's kind of like, expected. Do what the interviewer asks you to focus on, right? It's not about you in this interviewer, it's about you cracking the interview. So focus on what the interviewer is asking you. Where are they asking you to like pivot? If they're like, okay, you talked about this, right? Can we talk a little bit more about this? What do you mean by this? Or let's just dig deep into this particular topic and talk about this in a bit more. Like, what if this happens? What if that doesn't happen? Great. Forget about everything else. Focus on what they're asking you in the moment, and just like focus on that and just like solve that. If they're like, okay, I get it where you're going, like, okay, don't worry about it anymore. There's a different question I want to ask you. What would you do in this scenario? Great. You should be able to pivot immediately. You should be able to be like flexible and open-minded to change the topic and start thinking about a very different problem that they've asked you. And you can always say, I don't know about this, or you can be like, can you clarify? I don't understand. That all that is fine, but you should be competent enough to like switch or pivot if they're asking you to think about something different, right? So that's again part of your skill that you should be able to. That is why these kind of interviews are very difficult, because at the first half an hour you're solving something, the next half an hour you're talking about something very different that the interviewer is now curious about or wants to assess you on. And there's no right or wrong answer. We will look at, when we are looking at the problem, the system design interview question later in this session, we will see like there's no right or wrong answer. As long as you can come up with, hey, this is my design and these are the pros and cons and these are the trade-offs, it's fine. Right? So you should not worry about, oh my God, I gave a wrong design, or this is the perfect design. Why would you change it? No such thing. Right? And that's also why this kind of interview is a little tricky, because you can come out of the interview thinking, oh, my design was really good. I think I addressed everything. And the interviewer would be like, that was a really bad design. I wouldn't do that. So, it depends, but you should not think of like, my design is right or my design is wrong. This is my trade-offs, this is my assumptions, this is my scope, and this is what my design should look like. It's okay to mention you don't have familiarity with the technology tool concept, right? Like, I don't understand what a hedge fund is, so I don't know how to design a tool around it, a software around it. Like, can you explain me? Right? A good interview will obviously do it. Okay, if you're talking about streaming and they are like, okay, are you familiar with Kafka? I'm not. I don't have experience at work. I know what the technology is, but I don't have like a working knowledge or hands-on knowledge of it, so I can't speak to it much. Cool. It's okay to say you don't know, or you don't know enough, or you are not experienced. If you don't say it, the person will drill you more on it, and then because you don't have the knowledge or experience, you might say things that are not true or not like smart, and that will give you a negative point in the interview. So you'd rather not say than like say something just to try to clear the interview. So not saying things like, I don't know, or I don't understand, can you explain, or can you clarify, is really good. People really appreciate that. Discuss trade-offs, right? I said, this is my design, these are my trade-offs. If you're scaling, it's a very different design, this is what I would do. If your feature changes, or we want to pivot to a different kind of product, this is how I'm going to change my design. You have to discuss your trade-offs, right? Like, why this design and how would you change it, the pros and cons of your design, the technologies you picked, everything. Because that is where the real skill is. Given any problem statement at work, how and you're asked to design it, like, why did you come up with this design of anything else, right? So you need to make a case around it. These are my trade-offs, and this is my pros and cons, and this is why, for now, this is the design that will work. Yeah, don'ts. When someone asks you like, hey, design Chipotle drone delivery, don't start like coding. System design interview is not a lead code or your coding interview, okay? Unless they ask you to. If the interviewer asks you to like, okay, can you write an API? Can you write your data schema? Can you write this SQL query? Can you write this object model? Just write the code in whatever language you picked. Unless they ask you to, you're not supposed to code. You can whiteboard, and visualization helps, but you are not supposed to code. That will be seen as a negative in the system design interview. In other interviews, coding interviews, that's what you're doing anyway, right? So that's fine. No need to code the API. You can talk about it, but you are not supposed to whiteboard the API unless the interviewer asks you, right? Like coding the API, any kind of other coding, any kind of like drawing data models, all that is not necessarily considered a pro unless the interviewer asks you to. Because system design interview is all about discussing ideas and brainstorming, not necessarily coding. We're not assessing your coding skills. We're assessing your problem solving skills, attention to detail skills, analytical skills, design skills, like how you communicate, your knowledge of technology, and very different, there are a lot of concepts that go into like system design. That kind of knowledge. We looked at the design considerations, right? Like there's so much there. I just mentioned one line, but like there's so much that goes into scaling and reliability and security. Those are the things we want to assess, not like how well can you code in Python or Java. It's a different interview, it's a different assessment, right? Don't be quiet. Like this is discussion. This is a collaboration. Think of it as like, this is my future colleague, and we will have some project in the future where both of us are going to get together and design something or solve a problem. So how would we address this? So it should be a collaboration between two people. It should be a discussion, and together you have to come up with a solution. It's not like, okay, I'm being interviewed, so this is my idea. Interviewer, you better agree with what I'm saying. It's not like that. Together, we're going to come up with this design that both of us now like, and both of us are on board with, right? So it's a collaboration. It's a team effort. That's how you have to see these interviews. And the interviewer can also trust you more, and they'll probably like you better because, you're very easy to talk to, and you just involve them in your design thinking, in your design process, rather than just like do whatever you want and they're just like, they're listening, right? Don't delve into technology. Like I gave the example, right? You can mention, if you're talking about PubSub or some kind of streaming, you can say, we might use Kafka to do this, right? But if you don't know anything about Kafka, or if you can't talk about Kafka for an hour, don't mention it. Or don't mention it beyond, there are like streaming technologies like Kafka, this and that you can use. But like, don't get into Kafka and then your entire interview is about how Kafka works. Like bad, right? Because you might know about it, but I was not able to assess you. Right? That is not the assessment I'm looking for. I'm not trying to understand how much you know about AWS or Kafka or Redis. I want to see, like, you should know enough to use the technology to solve the problems, right? But I don't want you to know the ins and outs of how AWS works and how Redis works and this and that. If you get into that, it's not good. There is no benefit to it. Don't delve into a module or a domain. Like I said, right? Like if they're asking me to design like a hedge fund software, I need to know enough about hedge funds to come up with a technical system design. I don't have to talk to the interviewer about hedge funds for an hour. That is not the point. Don't get into that one module or one domain or whatever your domain is for like an hour. Like cap it. Is it enough for domain knowledge for me to design this system, the technical design of the system? Yes, great, move on. That is not the point. The point is not to talk about domain for an hour. This is a technical system design interview. You have to be technical. So I know we have like 15 minutes. I'll try my best to cover everything. But this is like an interview question that is very common. That is asked in like startup interviews, big companies, everything, right? Like designing Instagram, right? Like if they're not the best interviewer, they will say design Instagram and that's it. If they are a good interviewer, they'll be like, let's just design Instagram for like 10 users. And if time permits, we can talk about scaling. We can talk about now this Instagram that you have designed for 10 users, how will you design it for the Instagram that we have today, right? How will you scale it to millions of users and like much more features and stuff like that? Same with Twitter or YouTube, right? So here I'm gonna like talk about like this question. We want to design Instagram for 10 users, and then you want to scale up, right? So this is a very common question. Now, if someone asks you this kind of question, there are certain ways to like start. This is a template or framework, right? You want to start with understanding the requirements or the components, right? Like, what are the requirements? Let's start there, right? Functional requirements would be like, consider the product requirements. Like, I need to have like an Instagram profile. Then, you can show your post there. You need to have followers and following. You have a profile description. You can, let's say, add stories. You can post. You can see, you can have a feed. You can like other people's posts. You can go and see someone else's profile. So these are all the functional requirements or product requirements. This is my product, Instagram, and these are the features I have, right? So this would be your like functional requirements that you need to talk about, or product requirements. Non-functional requirements would be like, consider the system design principles that we looked at, right? Or system design considerations. How much do we want to scale the system to? What does performance look like? What would be the availability of Instagram? How secure is the data? What does the UX look like? Right? Like, how reliable is my system? Right? Like, what does monitoring look like? What are some of the errors the system will have, and how would we handle it? Now, this is the technical side of requirements or non-functional requirements that you also need to think about when you're designing Instagram. So when you talk to your interviewer, you split, when you're whiteboarding all this, split the requirements or ask the right questions around what are the functional requirements and what are non-functional requirements. I mentioned a lot of different things. What you can do in an interview realistically, you can be like, hey, we're just designing for 10 users. Let's just have like 5 features. Let's not have all the 50 features that the actual Instagram app has today, right? Let's just not worry about stories. Let's just not worry about reels. Just focus on posts. Just focus on a simple profile, and that's it. Let's just start with that. It's just 10 users. We don't have a lot of features. When we're scaling up, we'll think about scaling up to more users and also more features. Then we'll think about designing for reels, designing for stories, bunch of different things, right? So you can always cap it. You can be like, current Instagram has 50 features, and let's just focus on 3. Okay, and current Instagram does a lot of different, has a lot of non-functional requirements, and let's just focus on like few, right? We don't have to worry about scale right now, so let's just not worry about that. Let's just worry about like security or like privacy or like availability. Do we need load balancing? Do we need caching? Stuff like that, right? So that is what you want to discuss and clarify. Data models, right? Like, will this application have SQL data, no SQL data, caching data, partition load, all of these things, right? Like, these are the fact that you're talking about these things tells the interviewer that you have knowledge, and the fact that you're like, okay, we might not need caching, or let's just do caching, let's just do data partitioning, let's just do load balancing. And this is why I'm recommending we do that, even if it's for 10 users, right? We might need a SQL data store and a NoSQL data store. And this is the reasons why I'm suggesting this as a part of my design. Now, this is all the things. It's like you have to convince the interviewer on your design and your thinking and the choices you're making. Backend services, right? You have to think about that. Because Instagram is just for 10 users right now, is it a monolithic application, or you want your system to be extensible? So you are designing it as a microservice, like from day one. Why would you do that? Right? So like stuff like that, you need to like, for 10 users, if you're doing a monolith, it's fine. But if you're thinking about scaling to millions of users, you might want to design it as a microservice, right? Microservice architecture. So why would you do either? Again, not right or wrong, trade-offs, right? I'm doing this for now because this is my scale. I'm doing that because I'm going to scale up. Extensibility, the stuff like that you need to talk about. Will there be any internal, external integrations? Is your Instagram application having some other external integration, some other technology or tool that you are integrating with for whatever reason? What does that mean, and what will that look like, and what does that integration, is it internal, external? You need to talk about these things. APIs, right? Do we even have APIs for this application? Are you designing an application which will have APIs? Fine. If yes, what do those APIs look like? And tie those APIs with the functional requirements or the features that you mentioned before. They should be aligned, right? Are you using REST APIs? Are you using something else? Fine. Like, are you using GraphQL, REST API, what? Like, and why, right? They're very different things and have very different purposes. Why are you using both, and why are you suggesting that? You can talk about it. User experience, right? You can be like, I'm only designing it for mobile apps, iOS only, not Android, not web. So this is the user experience I'm going to give, and this is what it's look like. Is that fine? Great. Security and beyond. This might be a little detailed, and it's like a complicated topic. What does your authentication look like? What does the authorization look like? Extensively stuff like that. Other design considerations, you can briefly talk about them. You can tell the interviewer that you're thinking about these things, and then they'll tell you, don't worry about it. Or if time permits, we will focus on security, authentication, authorization. But the fact that you thought about all of these things and you mention it upfront is great. It's wonderful. And then the interview will tell you, let's just design APIs and data models. Everything else, I get where you're going. I think I understand you. You have the knowledge. So let's just focus on this. And great. The fact that you mentioned everything and you thought about these things when you're designing for 10 users versus scaling is great. It shows knowledge, it shows skill. Next would be, once you talk through all this, you have probably whiteboarded all these requirements and you agreed, right? Hey, interviewer, both of us, we are designing this. Okay, this is the scope. Cool. Now, can I start visualizing? Start drawing the building blocks, like, or whiteboarding. This is what my system looks like. This is the module. This is the interfaces. This is the flow of data. Now you visualize, and then you iterate over the design. You think about the big picture of the entire high level design. If you want to dig deep into a particular module or part of the system, you can talk about that, and then you can iterate. What if this happens, or what if a requirements change, or what if this happens? Okay, iterate through a design. Okay, then you can talk about pros, cons, trade-offs, and it's just like continuous like improvement after that. So you want to iterate. The interviewer might be happy without you iterating, but the fact that you can think about these things and just even like talk about these things is like shows a lot of skill. So when someone asks you like design like Instagram, I just came up with certain features, like I said, right? Like Instagram has a lot of features. Let's say for my interview with you, I'm just like gonna talk about these features, and I'm just gonna restrict to this. Is that okay? Interviewer says yes, cool. So for my design, I'm gonna say, okay, for Instagram for 10 users, let's just create a post and only images and videos allowed, right? We don't want like audio files for now. Let's just do images and videos, and that's it. And images can also be, let's just do PNG and JPG, nothing more. Any other kind, HEIC, we don't want to allow that right now. So you can even further restrict that. It's not an overkill, but if Instagram is fine, it supports different images, but if it's a very specific kind of question, you can even further like decide, right? Like what does the media type also look like? So in the real system design, like at a job in a design systems, you're thinking about these things. You may or may not mention the media type, but start simple. Like I'm just gonna we'll just have like post creation and only 2 media types, images and videos. And these are the formats we support to begin with, right? Users can update a post, delete a post, follow, unfollow, view account profile feeds. And then there's like user management, right? Like what does my account look like, security, 2-factor authentication, stuff like that, delete an account, all of that. And then like notifications, right? Someone follows me, someone likes my post, they get notified. So I'm only want to focus on like these features. There's a lot more, but let's not worry about that right now. If time permits, when we scale, we will think about those things, because then it becomes a slightly different problem you're solving. And the design has to accommodate that. Non-functional requirements would be, we are only designing for 10 users. Okay, and we will have a mobile app and website. Mobile app can be like native iOS or Android. Fine, you can talk about that. We only process images and videos when you're writing your description, or we'd only limit it to like 255 characters when you're writing, or even your post, right? If you're adding a new post, we will only limit that post to like 6 media files. So you can only add like 6 images or 6 video or 6 files, either image or video. So you can be that specific, and you have to be that specific when you're interviewing. Like that's why these kind of questions are actually really good in interviews, because a lot of us know about YouTube and Instagram and like Facebook or Twitter, whatever, right? We have familiarity. So you already know the product, you can come up with your own recommendation around it, and it looks really nice when you're interviewing. It shows skill, it shows decisiveness, it shows that you know the product enough that you can make decisions. You can make, as an architect, you can make a decision as to this is what features I'm going to support, and these are the requirements that I'm gonna come up with, and these are the requirements I'm going to prioritize, and I'm going to design my system around this. So it shows a lot of skill and knowledge around technology and product as well. Services, right? So then next you want to talk about services. Like I'm going to go with like a microservice architecture here, not monolith, because I'm assuming this app is going to be very popular. People are going to like it, and it's going to scale, and it's going to scale quickly in the next like 5 years. So, I don't want to rewrite the whole application. So I'm just going to think about extensibility and flexibility from the get-go. And I'm going to pick a monolithic architecture, and I'm going to have like 7 different services, which together is my product Instagram, right? So I'm going to have like a post service that takes care of post creation, updation, deletion, media service that takes care of like processing my images, videos, feed service, right? Like user management, which takes care of account, like your user profile, description, all of that, account management, which is deletion, security, etc. Authentication service and analytics service, right? Like you have all this data, you're doing some kind of analysis on it to, just it can be as simple as logging or monitoring, whatever, right? Whatever analytics you care about at that point. And then data store. So I'm going to have different data stores. I'm not going to like have one kind. So I'm going to have like relational and non-relational databases for user information feeds, posts, etc. I want to store them in a relational manner, right? Because account is linked to a profile, is linked to a post, is linked to some media, right? So they can all be relational. My actual media storage, which is images and files, can be non-relational, right? So that's fine. So you can come up with your recommendations on this is where you're saying, right? SQL versus no SQL. And this is a decision you need to make. So this is my design and this is what I'm proposing. If the interviewer says like, why would you want relational database? You should be able to explain it because all these different things are linked, right? It's like user is linked to like a post, is linked to like account, stuff like that. So that's why you are suggesting in this particular design a relational database. There might be a different way to solve this. If yes, if the interviewer is curious, you can also come up with a different proposal, a different design, and then accommodate your design accordingly. If the interviewer says, let's just do monolith, great. You don't have all the 7 services, all of your features will be one application. And once you have a monolith, then now you have to talk about the trade-offs, like pros and cons of how that monolith will grow and everything. And you should know enough to talk about that as well. If the interviewer asks you to pivot, right? So you should know about that too. Tables. Then if the interviewer is focused on like write your APIs, write your data schema, you can talk about tables and relationships. If they have not told you anything, then still go ahead and talk about it because knowledge of like databases, data relationships, and data schemas, data modeling is crucial. And you as engineers will do this in your day-to-day life. So if you're proactive and talk about it, unless they ask you not to, then it's kind of really important. Like this is the meat of it. How do you deal with data and your APIs and stuff is really the meat of like a system design interview question. This is the most important thing. So you can talk about, you can say stuff like, I'm going to have like a user table and a feeds table and a post database. And these are some of the data points I'm going to store. Like I'm going to store like a timestamp of when the post was created. And, like there will be some kind of primary key. This post will be associated with some user ID. So all these kind of things you can talk about. There might be a lot more data you're storing, but you can start with like, hey, these are some of the basic things that I care about. You can even draw a table or you can just write this down. You can draw like different tables and you can show the relationship between them. Like, it's like 1-to-1 relationship, many-to-one. What is going on there? What do your primary keys look like? What do your foreign key look like, right? What is the relationship between different databases? So, those are some of the things you want to also talk about. For example, like user database links to like post database, media, data store and account management, right? Stuff like that. So you can also talk about relationships, and you can draw some kind of like entity relationship diagram. If you're good at it, you can feel free to draw that as well. Like interviewers appreciate that kind of visualization as well. Next would be APIs, right? So like if they ask you, and if go talk about APIs. When you create a post, it's going to be an API. It's going to be a post API to create a REST API of like kind post where you're going to create a new post, right? Or if you want to get someone's, if a user is going and seeing someone else's profile, it's going to be a get REST API, right? Stuff like that. So you can come with it. I have mentioned REST here because that is what I'm choosing in this particular design. But you can pick the tech stack you want and how you want to enable these features, right? So I'm going to have like REST APIs for all my functionalities, and I'm going to rate limit my APIs to like 50 requests per profile or 50 requests from that user or that profile in the in like 5 minutes. This is again, that is not, the latter is a non-functional requirement. So these are some of the things you can talk about. You can say why you're thinking about this thing and why this is something you want to implement. Or if you don't know what rate limiting is and stuff like that, then don't mention it. But if you know and you have a solid case on why you're doing this, then you should feel free to like talk about it, because they can, in the next 10 minutes, they can stop you right there and talk about rate limiting for like 20 minutes. You should be able to talk about it, right? With respect to what rate limiting is, and with respect to this design as well. So yeah. Are you having an API gateway, right? What does that API gateway do? Where is it placed in your system, right? You have all these different modules. Where is it placed, right? Is it between client and your backend? fine. Like, where is it placed? Like, how many instances do you have? What is it actually doing? Is it doing more things? Is it doing less things? Do you have a load balancer? What does it look like? Is it for servers? Sorry, is it for web servers? Is it for other resources? What does that look like, right? You have an authentication service. Is it something external, or is it your own authentication code or application you have returned and you're leveraging something in-house? What does that look like, right? Is it authn or G, permissions, roles? Authentication is a very big topic. You can talk about it for an hour, but you can always cap it, right? Like, all users have like read access to everyone else's everyone's profile they are following, or every profile that's public, right? You can read everyone's, you can go and see anyone's profile that's public. You have read access, but if it's private, you don't have the read access. You cannot see their post. And that would be a nice example, right? So stuff like that you can come up with. And that is the authentication authorization you are in your design thinking about. Caching, right? Like, depending on a geography, you want a data partition, but you also want to cache. So what does that look like? Are you caching images? Are you caching videos? You're caching posts? Where are you caching all this, right? Is it like something in CDN? Is it Redis? What does that look like? Data partitioning, right? Like, you have Instagram for people in US and for people in Malaysia. Fine. What does that look like, right? How is your data partitioned and stored? You want to think about that. Is your data on-prem or is it on the cloud? If yes, what technology you're using? If you know what technology, mention it. If you don't know, it's fine. You can be very generic and say, okay, I would want to store it in the cloud because so-and-so reasons. I don't know what technology to pick. I would want to research and come up with an answer for that. But some kind of cloud technology is better than on-prem. That's fine. That's a good answer. Application servers for hosting applications, right? Like, how many app servers you have, how many web servers you have. You can talk about, you can again make assumptions and talk about this. Do you use Docker Kubernetes for container orchestration, right? If you know about these technologies, mention them. If you don't know, it's fine. External service integrations, right? Do you have any kind of monitoring or logging? You would want to log your application. You don't want to use Splunk for that. Or you have your APIs and you want to use Datadog for monitoring your APIs and performance. Fine, you can mention stuff like that. If you have the experience, then you can talk about that. It's fine because a lot of companies are using these tools. So this is interview specific that, if I know I have experience with Datadog. If I'm interviewing someone who knows Datadog, I'll be more comfortable that, when they join the team, they'll know the tools, the tech stack, the system, it'll be easier for them. So it just helps. But it's not like compulsory. You get like some bonus points there. So stuff like that is what you can also talk about. Now, when I think about like the architecture, your whiteboarding might not look exactly or this pretty, which is fine. But this is one design of Instagram, right? You have some kind of client here, it's a mobile. Right? You have Instagram server, you have a user service, which with the data store, it's like authenticating you, right? Once you are an authenticated user or logged in user, I suppose, then you can look at feeds, you can create your post, you can add your own media, right? And it will be processed in some way. And all these different microservices here have their respective data stores. It can be SQL, NoSQL, something else, right? It can be on-prem or cloud, fine. And they all are linked to some kind of messaging service, which kind of like takes care of your like data flow and your logging and stuff like that. So this is like one example of your Instagram design that you can talk about. Like, very simple. For 10 users, this works. If you want to further drill down, if they're asked to design or talk about like a data model, this is the diagram you can draw, right? Like, I have my user feeds table, right? And I have some kind of primary key. I have my post comments table, post likes table. Post table has different other, like, post is like a lot of data. You want to further drill it down into post comments and store it in a different table, and post likes is a different table. And they have one-to-many relationship, right? Because one post can have many comments and one post can have many likes. So you want to store these things separately. Whatever reason you want to store it in different tables, you can come up with reasons, right? You want to have a more fragmented, more structured data. Analytics on post likes table versus post comments table, it's easier. So you can come up with your own reasons for trade-offs as to why all the post data is divided into like 3 different tables in this example, right? And this is a relationship. And you can talk about these kind of things as well. You have a user follower table is linked to a post, user table is linked to a post, user feed, right? So like, what does the relationship look like? And this is your flow of data. right? From a user, they have their posts, they have the feed, they have followers following. All of this data is relational and they're all linked, right? And these are the relationships. One to n means one to many. Like one user can have many posts and one user can have many followers, stuff like that. So this is something you can also draw if they or whiteboard if they have asked you to. But this should be your mental image. Like this is what you're thinking when you're proposing like a data schema or data modeling, right? That this is the idea you have. And it can be like, this comes with practice, that you can have a mental model of this and you can actually draw it. But the more system design interview practice you do, this will come naturally to you. When you're at your job, when you're actually architecting, these are the things you're actually drawing in design docs. These are the things you'll be presenting and people will give you feedback on that. Let's not have a post ID, or let's rename the post ID to something else, or let's rename the user ID to username. Stuff like that, nitpicky people can be, and you'll get all sorts of feedback on that. Stuff like that is what you need to like think about. If time permits, or if this is what they asked you to do, right? Scaling. We talked about all these topics in our previous session. The recording is on YouTube and the Backend Story Group playlist. But when it comes to scaling, there are like, scaling means like these 3-4 things, right? You're talking about load balancing, you're talking about caching, you're talking about data partitioning, and also distributed storage. Distributed systems come with their own set of challenges and requirements and expectations. So you need to have knowledge of distributed systems as well. So when you're thinking about scaling, you might not be able to necessarily draw a scaled up architecture. It's very time consuming. Even talking about this, each of these topics are like quite like detailed and complicated. There's a lot there. But you want to talk about load balancing, right? Incoming requests, network traffic, how is it distributed among all your resources? How are you preventing your systems from not getting overloaded or burnt out, right? These kind of things you want to talk about. It can be as simple as, I have 2 databases, right? One is the core database, the other is the backup database. So, if the core database is overwhelmed or something happens, I can redirect all my traffic to the backup database and everything is fine. My system is reliable, right? It's working, it's available. Stuff like, it can be as simple as that. But this is what you want to mention, because this shows knowledge of like load balancing and reliability and availability and all of these kind of things, problem solving and error handling and stuff like that. Caching, right? Your system is optimized for read operations. Then like, how would you enable that, right? You want to add like, you want to reduce the load on servers and databases. So you introduce like a cache layer. And this helps with like distributed traffic management. And if you want to introduce a layer of caching for your Instagram app, okay, this is how that layer looks like. This is where it plays. I'm using Redis for it, let's say, and this is the data I'm going to store, because Redis is a key value store. So this is the data I'm going to store, and this is how it's going to optimize my read operations, right? So you need to come up with a case as to why you're doing this, what is the tech stack, and what is the benefit. Data partitioning is splitting the data across multiple tables and data stores. You need to come up with like, why are you doing it? Okay, it improves maintainability, performance, availability, load balancing, cost effectiveness. Are these things they need to consider as your application scaling? Probably yes. So like, this is data partitioning will help you with that. Fine, you can talk about that. Then you can talk about, you want to horizontally partition or sharding versus vertical partitioning. What does that look like? And why would you want to do one versus the other? Or you can do hybrid, you can do both. And what does that look like? Distributed storage, again, SQL, NoSQL databases. And if you select like a distributed store, which is on the cloud, it will come with its own benefits. You need to know how to integrate with such a system, and your application should be smart enough to like collect data from different data stores and like come with a holistic, clean view of your data to the customer, right? What does that look like? Once you think about distributed storage, you think about the CAP theorem and trade-offs therein, and you need to understand like, is your system like, you can only provide either CA, AP, or CP, and you need to talk about what your system is providing and why. On-premises cloud infrastructure is a very common topic. Pretty much everyone is transitioning to cloud, but you need to have a case as to why on-prem versus cloud, and which cloud technology you're choosing and why. And one is this microservice, right? If you're doing something small, that's not going to go with monolithic. But if you have something that's going to grow in the near future and going to have a lot more features, there's potential, maybe start with microservice. It's more work upfront, but it saves you time later. But that's your trade-off, right? Is that the case though? If yes, then you need to, that's your trade-off, your pros and cons. You need to come up with those kind of decision making. This is another design of Instagram where, like I have like, this is more infrastructure side where we are talking about scaling. This is your interview can be like, let's just like shard shard the Instagram database or partition it by posts. And let's just focus on that for the next 1 hour. Fine. This is the design then you're going to talk about for an hour. Like, we have like client where they upload some kind of media. There's a media service and data store. There's a post service. There's some identification service just for your post IDs though, not for the user. And I'm going to shard because my Instagram is now dealing with like 5 million users. I'll have to shard all my data into like 10 different instances. What does these data stores look like? Are they SQL, no SQL? Are they geographically distributed, right? Or just in one geography? What is my sharding or data partitioning algorithm or routing algorithm, right? Here I'm just going to do is like post ID, which is let's say an integer, and I'm going to just do modulo operation by 10. And whatever the number is, that is where my partitioning or my data is going to go. So if post ID is some number modulo operated 10 and the answer is 8, fine, my data will go to that partition. That is my routing algorithm. And there are different routing algorithms. We talked about this in the previous session. So if you just want to like data partition your posts, right, and you want to talk about that for an hour, that is the problem you're solving. This is how your Instagram design will look like, which is very different from our previous diagram. Right. This is a different kind of Instagram design where you are only focused about like post or status creation. Let's just focus on like Instagram post creation and let's just design for that. So then you have like a different kind of like system, like there's some kind of token service, all your media is on S3, you have like your post and you have like distributed Redis, which is used for caching. You have Cassandra for like NoSQL data store. You're doing some kind of queuing, for like logging and monitoring and all sorts of stuff. And you have an API gateway in place too. This is a very different infrastructure and a very different kind of design that you're talking about. And in this design, you need to know about Redis, distributed Redis. You need to know about Cassandra. If you've not heard about, well, at this point, if you're designing, you know about it, Kafka or SNSQ, right? Or some kind of SQS system. So why are you using that? Why at this point in your design? Why do we even have an API gateway? What does time generation system mean? What does video generation system mean? Why do we even need some kind of queuing system here? You need to come up with like, this is your design, this is why we need a queuing system, and this is the benefit of it. So all these things you can talk about. Like I said, right, we have looked at like very different designs of Instagram. None of them are necessarily wrong, but you can design the same thing, same question, very different answers, very different technology, very different problem you're solving, but you're still designing Instagram, right? You're still addressing that question. But here I'm talking about very different things compared to like, or focused on a different sub problem than in the previous diagrams, right? Here we are focused on like APIs. So I'm gonna have like couple of services. They have an MVC design pattern. That is how they're designed. And it's a traditional web server versus a browser native app, right? These services are serving like a different client. They're all linked to an API gateway, which is a single point of entry for your backend. So your front end is both MVC. This is your traditional web application versus your browser or your native app. So two different kinds of clients or front ends. They both talk to the same API gateway, right? Which becomes a single point of entry for your entire Instagram backend. And in the backend side, we have like 3 different services: a product service, recommendation service, a review service, and they have their own REST APIs. For this one, we have an AMQP. The protocol is different, and between your API and your service, the protocol transition needs to happen. So your system as a whole needs to deal with all different services, all these different interfaces, different kinds of data, so that either of these clients or front end still sees the same data, still sees the same experience, right? So your application needs to be much smarter to deal with all the different modules and protocols and interfaces. This is again a different design, right? Like here we are talking about like user uploading a photo and some kind of notification about user activity that you're just like pushing. User update the description or deleted a post, right? It's just user related information. It's just some kind of notification that you're logging, let's say, so you are seeing all the user activity and you just like going to some notification server and eventually just stored in the database. And this is your user photo upload flow. When a user uploads just a photo, this is not even video. What happens? Some kind of load balancing happens. You have some kind of API gateway. There's a post service, newsfeed service, right? All of these things, you can walk through. You can only focus on like upload a photo feature for the entire 1 hour, and you can draw this and you can talk about this, right? Here we have not even mentioned what the DB will look like. Is it SQL, NoSQL, Cassandra, Postgres? We even not even mentioned that yet. So that's why system design interview is a little tricky. There's no right or wrong, but whatever design you come up with, you need to like walk through what decisions you made and why, and what are your trade-offs. Always remember, I'm repeating this a lot, but this is the key. This is, you have to come up with a case and just like make sure the other person is on board with it. One thing I maybe forgot to mention is cost. Cost becomes a very important thing. When you're doing like real life, like architecture system design, depending on the cost, your design can change, right? Like AWS is very expensive compared to Azure, let's say. You know what, even though AWS is better, it has all these features, I'm going to go with Azure, even though if it is less features, because it's more affordable for me as a business, for me as a single person entrepreneur or company, right? Like this is more cost effective to me, I'm going to go with this. So what, I get 10 less features, I will deal with it. That is my trade-off or my choice. Cost becomes very important. It can really change how you're designing and what kind of tools or technology you're using. So it is the top 3 considerations, 100%. Again, this is a very different design. This is very core infrastructure, but the reason why I mention all these diagrams is like, you can make your design as complicated and as simple as you want. If this is a design you're proposing, you better know what cache is, you better know what a cluster is, you better know why you're using load balancing here, and you better know a little bit about CDN. And, why do you have async processing? What does a fan out mean, right? Like, you have notifications. Why do you have email and in-app push notifications? How are you going to deal with both? Right? So stuff like that, why do you need like a master and a replica, right? Like, what's the reasoning behind it? Why do you need a metadata storage, right? Why are you persisting that? What does that metadata mean? Is it about posts? Is it about images or media? Is it about the user? Is it about accounts? So if this is the design you're proposing, you better know a lot about a lot of different things, and you should be able to talk through it, walk through this system. So this is the end of it, of our system design interview session. This concludes our 3-part series about system design. We have more sessions upcoming. One is about introduction to ChatGPT or GPT-3. The next one that I'm doing is about SQL queries 101. And there's a lot more. You can go to our meetup events page and just RSVP. If you have any questions, we can address them now. And you can unmute, you can just ask, or you can put in the chat.
Prachi, there were few people who mentioned like there are some lines said that in interviews for entry level and junior level, deep system design questions doesn't come, like they won't ask. So is it true or not? Like,
the question is, will they ask these kind of deep questions or not?
yeah, because system design experience is learned from experience. So is it true?
Yeah, it depends. Like if you're someone who is a new grad or doesn't have a lot of experience, they kind of assume you don't have enough experience, or you have not worked on products that have like huge scale. So they might go back and ask you question about, hey, like you worked at this company, right? In the last 2 years, this is your first job. You worked at this company. What was the product? Can you talk about what that product means? They'll not ask you this is a system design interview. They'll ask you application design, or they'll ask you like, can you walk me through your product? What does it look like? Then it's up to you, depending on how much knowledge you have, how you want to answer that. Are they asking you about like, hey, object-oriented design? So these are my modules. This was my object. This was my design patterns. This was my data. And this is what I'm going to focus on. Or they are asking about like core system design and infrastructure. So that's up to you. If you don't have like a lot of experience or you're new grad, new grads, they ask generic questions, so they might entirely skip that interview because you just don't know. But they might just skip it. But if you have a little bit of experience, less than 5 years, usually they would ask you to just describe, what the application you worked on. Can you talk about it? And that. Then it's up to you. You want to do like a core system design infra round, or you want to just talk about like very high level product or domain stuff, and they'll assess you accordingly. But if you're someone who's senior and experienced, there will be a system design round, and we looked at all these diagrams, right? Those are the topics you want to talk, they'll assess you on, and you would want to talk about.
Then Mia, I'm sorry, I'm not able to pronounce your name. My Aga, I'm so sorry. So she asked, means they have asked that as a backend engineer, are you expected to have a fairly good knowledge about these concepts related to system design?
So for your day-to-day work, if you're designing and if you're doing architecture, yes, you need to know about a lot of different things, not just like core knowledge of concepts, high level, low level design, but also like, hey, like if you're implementing caching, do you even know like what Redis is or mem cache is? If you don't know, you'll have to go and like compare the two and present a case. I'm choosing Redis compared to Memcache, and this is why, right? So you'll have to do the research. So eventually, if you're doing system design or architecture or software design, this is some of the things like you need to like know. If you don't know, you better ramp up, right? But if you're someone who is not focused on architecture design so much, you don't necessarily have to. You need to know enough to just, work on your feature or your bug. But if you're an architect and designing, this knowledge becomes crucial. And the more and more senior you become in your industry, in your like experience, right? These are some of the things like you just need to educate yourself on at work or outside. Like I'm not using Memcache at work currently, but I know a little bit about it. I might not be able to talk about it for like 2 hours, but I know enough that, okay, there's something that exists. And tomorrow, if I want to design something around caching, I need to look at a few different tools, and then I can make a better decision, right? So that's when knowledge becomes important. If you have it, great. If you're not, when you're designing, you have to like do your research.
Then we asked, though people have answered, but does anyone use a beginner-friendly application that allows you to draw up and illustrate architecture? People have mentioned like I have used draw.io, then somebody has used axely.com and so far. So
Yeah, you can do Lucid Chart. Miro.com is good. If you're doing Zoom calls, you can even do Zoom's whiteboarding. I have in the past, like just like I have a whiteboard at home. I just have a second camera. I just drew there. Like I don't want to deal with the software, so I didn't. But I have used Lucid Chart, Miro. These are good. There's something called Mermaid .io or something. I forgot. That's also a good one. Microsoft Paint. Yeah, that'd be fun. But it can be PowerPoint, it can be Google Drive, whatever you're comfortable with. You're not going to get bonus points because you are using Lucid Chart versus Miro. Find something that is fast and you're comfortable with. This is your first interview and you're figuring out how to use Lucid Chart, and now you need to create a profile. Don't do that. Find the tool, stick to it, and whatever you're comfortable with. You're not going to get any points. In fact, if you take forever to like find the tool, and then it's taking you time to like, oh, this is the feature, or this is how I can, pick a button and like draw a box. Oh God, no one's going to appreciate that. Time is very crucial because system design, there's so much, and you can go in any direction. Time is crucial. So, whatever you pick, just make sure you're comfortable with it. Yeah, something that's easier. Even CoderPad, create like a free CoderPad account, open a CoderPad. There's a whiteboarding feature now. You can even do that. Why not?
I really has asked that if there is any discussion or even related to system level design for networking domain, or if there is a group for WWC group or community networking domain like TCP, Wi-Fi, or networking protocols.
That's a very good question. We don't have a group or a channel. around just networking, because um, it's very specific, and a lot of software engineers usually know at least basics of these kind of things, but there is no specific group dedicated just to networking and like core infra. Not yet.
Um,
Networking is just a part of like knowledge of infra, web fundamentals, how the internet works, stuff like that is like very foundational for software engineers. Front end, back end, full stack doesn't, DevOps doesn't matter. So unless you are like a network professional, it's just that would be very specific and very advanced, but we don't have a group for that. Sorry.
yeah, that's all for them. Like they asked before during the session and now.
Yeah, we said that you can make one. If you want to make one, come talk to me. We'll make it happen. Anyways, thank you so much, guys, for staying a little bit on board. Sorry, a little bit overboard with like time here, but really appreciate it. And I'll just quickly share one thing. I have like a feedback form. It's more of like if you have any ideas or topics for us, and if you want us to like cover more things, just let us know. I'll just share it in the chat. Yeah, this presentation is there on Meetup. Our Meetup, this presentation is there on our GitHub page, and this recording will be available on YouTube in like a couple of days. We also have a Slack channel, so feel free to like join that, ask your questions. That's our community, and you can RSVP for more sessions on our Meetup page. Yeah, I meant creating a network group. If that's something you're interested in and you want to lead, I can help you with that. So like find me on Slack and we can talk about it. Yeah, exactly what Larry said. Start a group channel in Slack. Yeah. Anyways, thank you everyone. And I'll hopefully see you guys in the upcoming sessions, and have a good rest of the week. Thank you.
Thank you everybody for joining.
Thank you.
Prachi, you can stop the recording.
Yeah, thank you.